In this lesson, we're going to be taking another look at the select function that we learned about a few lessons ago, and in particular, we're going to learn a mini syntax that is part of the tidyverse that is used for specifying conveniently which columns we want to select from a given table. So this mini syntax goes by the name of tidy selection, and it is not specific to just the select function. In fact, later on in the course, we will see other functions where the exact same syntax is used, so that is why it is good to get acquainted with it. So just as a quick review of how select works, we first have to load the tidyverse because the select function is part of that. Then we load our good old friend, the Galapagos land snail dataset, and assign it to the variable snails, so that variable looks exactly the way that we're used to. It has 4 columns, habitat, species, size, and shape, and it has 223 rows, each corresponding to a single snail individual. Now, we already know that the select function takes 2 inputs. The first input is the table that we're selecting columns from, and the second input is either a single name for a column or a vector of names that we want to select. Notice that I'm already using the pipe notation here. That is intentional. I am going to be relying on pipes from here on, so if you need a reminder as for how that works, watch the previous video. So I'm using the pipe to pipe the snails dataset into the select function, so I do not need to specify that the first argument of select is the snails dataset because the piping takes care of that. So in the select function, we select the 2 columns habitat and species specified as a vector, and if we do that, we get back exactly what we expect, a table with just those 2 columns, habitat and species. We also learned that one can deselect columns using the exclamation mark. So that looks a little bit as if it was the logical not operator, even though it has a different role here. The role it plays in this case is that if we put it in front of some selection, then instead of selecting those columns, we're deselecting those columns. So in this particular case, if we have exclamation mark of the vector of habitat and species, that means select everything except those 2 columns. And since the only 2 columns left are size and shape, that is exactly what we get in the result below. Okay, so this was the basic operation of the select function that we're already familiar with. But this is where tidy selection comes in, which again is a small syntax for being able to select columns more efficiently. As you see in the first bullet point there is something called literal selection, and that is exactly what we have been doing so far. So literal selection means that we literally specify, that is unchanged, the name of the column or the names of the columns that we want to select. So that is exactly what we have been doing so far. Range selection is similar to literal selection, except instead of choosing particular columns that we specify, it selects a range of columns from, to, and everything in between. Then we're going to be taking a look at starts with, ends with, and contains. Those 3 are helper functions that allow us to try to choose columns that either begin with some character string, end with some character string, or contain a character string inside them anywhere. Then we will be learning about the and the or patterns. Namely, we can combine different selection methods such that one or the other, or one and the other has to be true at the same time. And finally, we're going to be taking a bit of a deeper look at the do not match pattern, because as it turns out, it's more general than deselecting a literally selected column. It can be applied to any of the listed selection methods. Okay, so with this overview, let us take a detailed look at how each of these tidy selection methods actually work. So once again, literal selection works by just specifying literally the name of the column that we want to select. So if we take the snails dataset and then from that we select the species column, that means only that column is retained. Everything is as expected. Range selection works with the colon notation. So if we specify species colon shape, that means every column in between and including species and shape should be selected. So since, if you remember, the original table has the columns habitat, species, size, and shape in that order, therefore, if we specify species colon shape, that means that we're going to be selecting species and size and shape and discarding habitat, which is exactly what we see. Next up, let us look at the starts with helper function. And what that allows us to do is to pick out columns which start with a given character string. Here is a very simple and very typical example where we want to pick out those columns that start with some given letter. In this case, the letter S. So the way we do that is we select columns that starts with, we write that down, and then within starts with, we specify the character string S. So then all of those columns are selected, which happen to be species, size, and shape, because habitat starts with an H, so that one does not start with an S, so we choose these 3 columns. You're not obliged to just specify a single character for starts with. For example, it's perfectly valid to specify something longer like spec, and then only a single column is chosen because out of the 4 columns in this dataset, only the species column is the one that starts with the characters S, P, E, and C. Okay, so just like we can check whether the column names start with something, we can also check whether they end with something. For example, we could choose all those columns that end with the character E. This is how we select them, and then we immediately get back the result, which only has the 2 columns in its size and shape, because habitat and species, neither of them end with the letter E, but size and shape both do. Just as before, we can specify longer strings for ending. So for example, if we want to choose all those columns that end with P and E, then there's only 1 column that satisfies that criterion in this dataset, namely the shape column. Next up is the contains function, which is a bit more lenient version of starts with and ends with, because starts with and ends with only check the beginning, respectively the end of the names of the columns. But contains just checks whether the character string is contained in the name of the columns anywhere. So if we want to select columns that contain the characters P and E, then actually 2 columns are selected instead of just shape as before, because species also contains the characters P and E as its 2nd and 3rd character. Alright, so having learned about these methods that choose columns based on what they start with, end with, or what they contain, let's see how we can combine these together. The first method of combination is with the AND operator, denoted by the ampersand, as you can see on the slide. And what this does is it chooses those columns that satisfy both of 2 criteria. Here's a simple example. We want to choose those columns that both contain the character string ha, that is H and A, and also end with the letter E. So let's take this step by step. If we look at contains ha, what columns would that choose from our data set? Well, habitat contains ha as its first characters, and shape contains ha as its 2nd and 3rd characters. So habitat and shape would be chosen by contains ha. But that's not enough, because we also require that the column should end with the letter E, and since habitat ends with the letter T, that one is discarded and only shape is chosen. That is the only column that satisfies both the condition that it should contain the characters ha and also end with the letter E. The other method of combination is the OR operator, and OR works in a way that it combines 2 conditions such that the columns are selected if they fulfill either one or the other or both of these criteria. Here's again an example. We choose those columns that either contain the character string ha or end with the letter S. So again, step by step, contains ha chooses habitat and shape as we've just discussed, but ends with S will choose all those columns additionally that end with the letter S. There's 1 such column in this data set, namely species, so in other words we end up with a table that has 3 columns, habitat, shape, which contain the character string ha in them, and species, which ends with the letter S. So importantly, these methods of combination with AND and OR are not specific to working with starts with, ends with, and contains. They work equally well with literal selection and range selection. So here's a simple example where we select either the literal habitat column or any column that contains the letter Z. And as you can see, we selected 2 columns this way, habitat, which was literally selected, and the size column because that contains the letter Z. And the same thing can be used with range selection as well. So we could choose all those columns that are either in the range going from habitat to species, including those 2, or contain the letter Z. And then we get the three columns: habitat, species, and size. So those are the three columns that satisfy at least one of these criteria. Finally, let's just take another look at the exclamation point notation. Again, the exclamation point deselects instead of selects columns. So if we do literal selection, like select species, then to deselect the species column, we write select exclamation mark species, and then we're left with all the other columns in the dataset: habitat, size, and shape. We can use this on more complicated selections. So for example, we can select all those columns that do not contain the characters ha adjacent to one another. And there are two such columns, species and size. Why? Because we've seen that the two columns that do contain ha were shape and habitat, and those are now deselected, so we end up with just species and size. Finally, there's something that might look a little strange at first, namely there is a little helper function that simply chooses every column in the dataset. As you can see, it is called everything. And if you just invoke select everything with an opening and a closing parenthesis without anything written in between, then you just get back all the columns of the dataset unchanged. I know what you're thinking. If we just select everything, then we've really done nothing to the dataset. So why did we even bother invoking the select function in the first place? You're absolutely right. In fact, the everything function is not really meant to be used with the select function, but with some other tidyverse options which also rely on choosing columns, and some of those we will see later on in this course. So just keep this in the back of your mind for now. I know it looks a little useless, but bear with me and we will see in a few lessons that indeed it does have at least some uses. So to showcase how the various tidy selection mechanisms could be used in an example where they really make a difference, let us look at an ecological dataset. The link to the data is at the bottom of the slide. An ecological dataset that records the abundances of various organisms found at different plots within different sites. So the site and the plot within the site are the first two columns of this dataset. Then the third column is whether the given plot was grazed or not. The fourth column is the average height of the vegetation in the given plot. And then after that column, all the rest of the columns record the abundance of a given organism, and the given organism's binomial name is given as the column name itself. So we have Prunella vulgaris and Quercus robur and so on and so forth. All the way down, there are many of these columns. So they go all the way down to Populus tremula. Okay, so this is the dataset. It has many more rows than what I'm showing. It's just that so that they fit on the slide, I'm only showing the first 6 rows. If you will download the dataset and extract it, you will see that it has, of course, many more. Okay, so let's first of all read in this dataset and assign it to the variable grass. We're going to be using our good old friend, the readDelim function, because this is a CSV file, a comma-separated value file. So we specify the delimiter as the comma, and we read in the file and assign it to the variable grass. So far, so good. Now here is our question and our main task. How do we select just those columns that refer to the individual species? So if we go back to this table, in other words, how do we select just the columns beginning with Prunella vulgaris and ending with Populus tremula there at the end? How can we do that? Now, as it happens, there are several options for us here, the worst of which is that we literally one by one enter the names of all of those columns because there are so many of them. We do not want to do that. We want to be a little more clever. So let us look at some of the methods that we could use. The first of them is to try to rely on range selection. That is, we select all those columns that start with Prunella vulgaris and end with Populus tremula and everything in between. And if we go back to the table, we'll see that that will indeed select those species because we begin there, and then let's just scroll all the way to the end. We'll see that it ends there and selects everything in between. So all's well, this will do exactly what we wanted. But there are other ways to do the same selection. For example, instead of actively selecting for those columns that are the species, how about deselecting those columns that are not the species. So another way of achieving the same thing is to say, I want to select all those columns that are neither site, nor the plot, nor grazed, nor height underscore centimeter. Again, going back to the table, let me just scroll to the beginning of it. There we go. You see that site, plot, grazed, and height centimeter are the first 4 columns, and if we deselect those 4, then all the rest that we end up with actually contain the species. So again, this will be a perfectly valid solution. But if we're at it, then you might realize that site to height centimeter form a contiguous range of columns, so instead of unselecting each of these in turn, we might as well unselect the range site to height centimeter. This is perfectly valid because we put in the exclamation point there. That means that we're deselecting those 4 columns, and therefore we end up with only the columns that refer to the species. And finally, one more selection method is as follows. We can select all those columns that contain the underscore character and are not equal to height underscore centimeter. So to understand what that does, let's again go back to the data set. So notice that every column where there's a species follows the exact same pattern. Namely, you have the genus name and the species name, and the two are interspersed by the underscore character. And let's just scroll through this very quickly. You'll see that all of the species in this table follow that kind of pattern. So if we do this, if we select all those columns that contain the underscore, that will definitely choose all the columns that are the species. Unfortunately, it doesn't quite work because it will not only select those columns, it will also select the height centimeter column because that also happens to have an underscore in it. So what can we do then? Well, we can select all those columns that contain an underscore, but deselect the height centimeter column. And if we go back, that is exactly what that final selection method does. So in summary, all of these 4 methods do the exact same thing. So it's a bit of a question of taste, which one prefers. One can choose. It showcases that tidy selection methods allow very different solutions to the same problem, and it's not always obvious which one is the best. Maybe there isn't such a thing. There are various options, and one can rely on this to efficiently select columns. The point is that each of these methods is much more efficient than having to individually enter each of the names of the columns one after the other. That would be the thing that we don't want to do because there's simply too many of the columns. So that was it for today. That's the syntax for tidy selection. Thank you for your attention. We will continue in the next lesson.